Have you ever just stopped and wondered how the internet, well, works? How your computer can talk to a server halfway across the planet in the blink of an eye? It's not magic, I promise. It's architecture. Think about it like building a house. You absolutely need a solid plan before you even think about laying a single brick. So let's dive into the blueprint of our digital world.
And this right here is the core idea. Network architecture is that master plan. It's the blueprint that dictates how every single device, every website, every piece of data connects and communicates online. It's the grand design that makes the whole thing possible.
All right, so let's put a more formal definition on it for a second. Network architecture is the foundational design, structure, and organization of a network. You can think of it as the rule book that governs how data flows and how all these different parts work together in a way that's both secure and can grow over time.
A really solid architecture, it stands on four main pillars. You've got the physical hardware itself, the communication rules or protocols, the background services that make it all user-friendly, and the physical layout, which we call the topology. If you get these four things right, you've got yourself a working system.
Okay, so we've got the blueprint. Now, what about the actual materials for our big construction project? Let's take a look at the fundamental building blocks, the actual components you'd use to build any network, whether it's your Wi-Fi at home or a massive corporate data center.
First up, we've got the end devices. You might also hear them called hosts. Honestly, these are the things you and I interact with every single day. They're both the starting point and the final destination for pretty much all the data we send and receive. We're talking about your laptop, your smartphone, maybe that smart TV in your living room. These are the devices where our digital journey starts, when we shoot off an email, and where it ends when we finally get to stream that video we wanted to watch.
So here's the crucial thing to remember. This isn't just about your personal gadgets. It covers the clients, like your PC, but it also includes those powerful servers that host all the websites we visit, and even things like network printers. If you've ever set up a lab with a client machine and a server, guess what? You've already been working with two of the most important types of end devices. Okay, so you've got your end devices, but how in the world do they talk to each other? Well, that's where intermediary devices come into play. Just think of them as the plumbing, the wiring, and the traffic cops of our digital building. Their whole job is to manage the flow of data. Now, you probably don't see these every single day. On the left, we've got this massive enterprise switch that you'd probably find in a data center. But on the right, something much more familiar, a simple home router. The thing is, they both do the same essential job, directing traffic and making sure data gets where it needs to go. Let's break that down a bit. Switches are for connecting all your devices on one single local network, like in an office. Routers, on the other hand, connect different networks together. That's how you get to the internet. Firewalls act as the security guards. And access points, well, they give you that sweet, sweet Wi-Fi. And what's really cool is that the router in your house, it's often a 3-in-1 device. It's a router, a switch, and a firewall, all packed into one little box. And that brings us to our final physical building block, the network media. This is the stuff that physically connects everything together. If intermediary devices are the plumbing, then the media are the actual pipes that the data, our digital water, flows through. So data can travel in three main ways. It can go through copper wires, like that classic Ethernet cable you plug into your computer. It can travel through fiber optic cables, which use pulses of light shooting through tiny glass threads for just incredible speed. Or it can just go through the air itself as wireless radio waves. Think Wi-Fi and Bluetooth. So we have our materials, end devices, intermediary devices, and all the media connecting them. Now, how do we arrange them? Let's move on to the floor plans, the common design models that dictate how all these components are structured. The two most common designs you're going to see are client-server and peer-to-peer, or P2P. With client-server, you get awesome centralized control and security, but the big risk is that the server becomes a single point of failure. On the other hand, with P2P, things are simple and direct, but it can quickly turn into a security nightmare that's really tough to manage as it gets bigger. This right here is the classic client-server model. You can see you have multiple clients, your computer, your phone, and they're all making requests to one central, powerful server. This design is really the backbone of the modern internet because it's so reliable and secure. I mean, every time you visit a website, you're acting as a client requesting data from that site's server. And here we have the exact opposite, a peer-to-peer network. In this model, every device is an equal, a peer, and they're all sharing resources directed with each other without any central server in the middle. This is great for things like simple file sharing, but it just doesn't have the control and security that most businesses need. So we have this structure, we've got the floor plan, but how does a message actually get from one room to another? Let's look at the logical side of things now, the rules of the road that control how data travels through this network that we've just built. Your data goes on this little journey called encapsulation. It starts out as just data, right? Then it gets broken down into smaller segments. Each segment gets wrapped in a packet with an IP address, kind of like putting a letter in an envelope for the internet. That packet then gets prepared for local delivery before finally being converted into bits, the ones and zeros that are actually sent over the network. By the way, if you've ever used a tool like Wireshark, this is the exact process you're seeing in action. Now, working away behind the scenes, there's a whole bunch of essential services that make everything feel seamless. DNS is basically the internet's phone book. It turns names like google.com into IP addresses computers can understand. DHCP is like a friendly assistant that hands your device an IP address the moment it joins a network. HTTP is the language of the web, and Active Directory is the tough security guard for corporate networks, managing who gets access to what. Okay, so we've covered the blueprints, the building blocks, and the rules of the road. But why is any of this actually important for you? Let's connect all these ideas directly to what you're probably doing right now. Seriously, just think about it for a second. How is this complex world of architecture really a part of your daily studies or your work? You might actually be surprised. You're already doing this. Every single time you set up a DNS or a DHCP server in a lab, you're building a critical piece of network architecture. When you manage users with Active Directory, you're designing a security architecture. And when you analyze traffic with Wireshark or you build a virtual network in Packet Tracer, you are literally acting as a network architect. Let that really sink in for a moment. This isn't just some abstract theory from a textbook. The skills you're learning, the labs you're doing, all of that is real-world network architecture in action. You are already learning how to build, manage, and secure our digital world. So the big takeaway here is this. You've been handed the tools and you've been given the blueprint. You understand the components and you understand the rules. The only question left is, what are you going to build?